The most bizarre astronomical theories to date involve black holes. It's also terrifying to think of these black behemoths, which reside in a region of space where stuff is so tightly packed that nothing can escape, not even light. Given that black holes violate every accepted tenet of physics, it is simple to write them off as science fiction. Our universe, which began some 13.8 billion years ago in a fiery Big Bang, looks to be expanding and cooling, but it's conceivable that everything we perceive from within our own universe is only the outcome of being within a black hole that developed from another universe. If the black holes that originate in our universe give birth to young universes, it's possible that we ourselves were once black holes. Is it possible that we are currently within a black hole? Which black hole is the nearest and scariest? What would happen if all black holes collide? Let's find out. Black holes are extremely dense regions of space that cause significant gravity drains. Beyond a certain point, even light cannot escape the powerful gravity of a black hole. And in a hypothetical process known as spaghettification, anything that approaches too closely, be it a star, a planet, or a spacecraft, will be stretched and compressed like putty. Stellar, intermediate, supermassive, and small black holes are the different categories. Star death is the most well-known way that a black hole can form. As most stars approach the end of their lives, they will enlarge, lose mass, and eventually cool into white dwarfs. The largest of these burning objects, those at least 10 to 20 times the mass of our Sun, will either turn into stellar mass black holes or extremely dense neutron stars. When big stars near the end of their lives, huge explosions called supernovae happen. Such a burst launches the interior of the star into space, leaving the central core behind. While the star was still alive, nuclear fusion supplied a constant outward push that offset the gravitational pull of the star's mass inward. The star remnants of a supernova no longer contain any forces to oppose gravity. The star core starts to collapse in on itself as a result. When an object's mass is compressed into an incredibly small point, a black hole is formed. Black holes' strong gravitational pull is a result of their ability to cram more matter, mass greater than the galaxy's sun, into a small area. These stellar mass black holes could number in the tens of thousands in the Milky Way galaxy. Why are black holes strange? According to Rocket STEM, the largest black hole so far found is 20 times larger than the solar system. While this far more massive object rotates once every 3 months, the outer planets of the solar system orbit once every 250 years. On its outside edge, it moves at a speed of half that of light. Like all black holes, the huge ones have an event horizon that blocks our vision of them. At its center is a singularity, a region of space where density is limitless. We are unable to understand the interior of a black hole because the laws of physics have been violated. Time is stopped at the singularity's event horizon, and gravity is unbounded. Stephen Hawking asserts that black holes are slowly dissipating. Long after all stars have died and galaxies have been obscured from view by the unrelenting expansion of the universe, black holes will be the only things left in the cosmos. Black holes can range in size from star remnants a few times the mass of the sun to monstrosities tens of billions of times more massive, but nature has figured out how to make them all. That would be like equating the Great Pyramid of Giza with an apple. Black holes, which are matter-tuned, are inaccessible to anything, not even light. In his book, A Brief History of Time, Stephen Hawking popularized the terrible process of spaghettification, which would be experienced by everyone who entered a black hole. Your bones, muscles, ligaments, and even molecules would be torn apart by the black hole's powerful gravity, which would cause you to become spaghetti-like. The author, Dante, portrayed the inscription over the gates of hell in his poem, The Divine Comedy, warning people to give up hope once they enter the region. By the way, astronomers recently found the black hole that is closest to Earth. It is located in the constellation Telescopium, a cool 1,000 light-years away from our planet. It's almost as though it's banging on our cosmic back door. The astronomical wonder in question is a member of the HR 6819 two-star system. According to astronomers, there might be many more of these elusive celestial objects lying in plain sight. Researchers focused the MPG/ESO 2.2-meter telescope on HR 6819 in 2004 at the La Silla Observatory in Chile. An outer BE star and an inner star are the two stars that make up the stellar system. The star system may not be a typical binary star system. However, measurements made over 4 months discovered that the inner star appeared to be orbiting something at a very fast speed, almost every 40 days. According to their estimates, such objects had to be large and massive, with a mass nearly equal to that of the Sun and an approximate size of the inner star. They then started to limit their selections. Telescopes would be able to clearly see a star with the same mass as the thing in the inner star's orbit. The likely offender, an extremely massive black hole. However, if the black hole is so close from an astronomical perspective, why has it taken so long to be discovered? Black holes are extremely dense objects that eat nearby stars, as well as large quantities of gas and dust. They are frequently the remains of supernova dead stars. They have such a strong gravitational attraction that not even light can evade them. They are, hence, notoriously challenging to identify. However, sometimes there are obvious indications that black holes exist nearby. Black holes that slobbery consume neighboring matter leave behind radiation that telescopes can detect as proof of the feast. Black holes occasionally have an impact on the orbits of neighboring objects, causing astronomers to become aware of their presence. Other black holes that you might be familiar with are considerably farther away, such as Sagittarius A star, which is about 25,000 light-years away and is at the heart of our galaxy. The galaxy M87's black hole, of which we have a beautiful photograph, is around 55 million light-years away from Earth. We are aware that there are other black holes like the one at the heart of HR 6819. Some scientists estimate that the Milky Way alone contains up to 100 million black holes. What occurs when two black holes collide? Astronomers have speculated about this intriguing issue for more than 30 years. What happens when two black holes collide? Black holes that emerged from massive dead stars occasionally collide with one another inside of a galaxy, especially in double or multiple star systems. Even though no one had ever seen such a collision in person, it was a hot topic in theoretical astrophysics for years. It turns out that when black holes meet, a weird thing happens. They converge on one another as they spiral in the same direction. Then, in some circumstances, a gravitational slingshot effect ferociously flings them into intergalactic space and away from their host galaxies. Gravitational waves, a consequence of the merger, are the cause of the ejection process. The merging black hole can be physically propelled far from the point of merger by gravitational waves. When scientists used Hubble to scan quasar 3C186 in 2017, they discovered strong proof of such a process. The offset quasar's observations suggested that gravitational waves generated by the collision of two supermassive black holes were responsible for ejecting it from the galaxy's center. But how does this mechanism contribute to the formation of black holes? Could there be a lot of black holes outside of galaxies, where it would be very challenging to discover them? Meanwhile, there are two supermassive black holes that are likely to combine into one monster black hole, and they are located not far from Earth, according to astronomers using the Very Large Telescope of the European Southern Observatory, ESO. These black holes were found in the galaxy NGC 7727, which is only 89 million light-years away from our own galaxy. They differ in size and are very large, measuring 154 million and 6.3 million times the size of the Sun, respectively. Keep in mind that the Alpha Centauri system is only 4 light-years away, so 89 million light-years are only close in a relative sort of way for space. The fact that these supermassive black holes were discovered is even more amazing, given that they strangely lacked a prominent radiation signature that would have allowed researchers to detect them. This may result in the discovery of numerous other supermassive black holes. Scientists have discovered the nearest pair of supermassive black holes, and they believe that by colliding, they would create an even more powerful black hole. The two black holes' close proximity and similar velocities suggest that they will join soon, likely within the next 250 million years, creating a monstrous black hole. The merging of black holes like these could explain how the most massive black holes in the universe come to be. These black holes mergers may be the origin of the most enormous black holes in the universe. What is ahead for pairings of supermassive black holes? According to researchers, the extremely large telescope will provide additional opportunities to locate these couples, even at greater distances. This will make this kind of research more feasible in our local universe. Do we actually live in a black hole? Let's go back in time. The Big Bang occurred before the emergence of humankind, the Earth, the Sun, galaxies, and even the ability for light to shine. About 13.8 billion years ago, something occurred. But what about before that? Many physicists claim that there is nothing earlier. They believe that time started at the moment of the Big Bang, and that considering anything earlier is outside the purview of science. We will never fully comprehend what reality was like before the Big Bang, what it was made of, or why it erupted to create our world. Such ideas are incomprehensible to us. Unconventional scientists, though, are in disagreement. These physicists propose that just before the Big Bang, the entire universe's mass and energy were crammed into a minuscule yet immensely dense speck. Call it the beginning of a brand new universe. The size of this seed is estimated to have been nearly beyond comprehension. It may have been trillions of times smaller than any particle that humans have ever been able to witness. But even so, it's a particle that has the power to create every other particle, as well as every galaxy, solar system, planet, and living thing. This seed seems to meet the definition of the God particle perfectly. So, how is a seed like that made? One theory that has been floated around for a while is that the universe's origins took place inside a black hole, which is arguably nature's most extreme environment and was made famous by Nikodem Poplawski of the University of New Haven. Before we continue, it's crucial to note that many theoretical physicists now think there may be other universes besides our own in the past few decades. Instead, we might be a part of the multiverse, a vast collection of distinct worlds, each having its own bright orb in the real night sky. There is significant discussion about how, or even if, one universe is connected to another, all of which is extremely hypothetical and, as of now, utterly unprovable. One intriguing hypothesis is that the universe's seed is like a plant seed in that both contain an important component that is firmly compressed and encased in a protective shell. This is an accurate description of what occurs within a black hole. Giant star corpses that have become black holes. Such a star's core collapses inward as it runs out of fuel. Everything is being gripped by gravity with increasing ferocity. There are 100 billion degrees of heat. It breaks atoms. It shreds electrons. These fragments are further distorted. By this time, the star has become a black hole, which implies that no light can escape from its powerful gravitational pull. The event horizon is the line separating a black hole's interior and exterior. There have been numerous reports of enormous black holes, some of which are millions of times more massive than the Sun at the heart of galaxies, including our own Milky Way. You can calculate an area that is infinitely small and infinitely dense using Einstein's theories to determine what happens at the center of a black hole. This hypothetical region is known as a singularity. But in nature, infinities are uncommon. The mismatch is caused by Einstein's ideas, which produce excellent computations for much of the cosmos, but tend to fail in the presence of extremely strong forces, such as those present at the creation of our universe, or inside a black hole. According to certain physicists, including Dr. Poplawski, the matter inside a black hole eventually reaches a point where it can no longer be crushed. Even while this seed is exceedingly tiny and weighs as much as 1 billion suns, it is real, unlike a singularity. Due to black holes spinning, the compacting process stops. They rotate at a rate that may be very near to the speed of light. And because of this spin, the compacted seed has a tremendous degree of torsion. It's twisted and compressed, like one of those silly spring-loaded snakes in a can, in addition to being little and heavy. In other words, it's feasible for a black hole to act as a conduit, a one-way door between two universes. This indicates that it's possible for you to wind up in a different world if you fall into the Milky Way's black hole, or, at the very least, for the fragments of you to do so. The hole only serves as a connection, much like a shared route connecting two aspen trees. This other universe isn't inside ours. What about all of us who are present in this universe? We might be the offspring of an earlier, different cosmos. Call it the mother of all things. Even though our universe has been quickly expanding for the past 13.8 billion years, we could still be concealed beyond the event horizon of the black hole that our mother universe was created inside. Understanding massive black holes in the early cosmos may benefit greatly from more research on black hole merger. Our questions about black holes may continue to be clarified by additional research into how black holes behave in more recent times. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.